About 2 years ago, a guy named Pete Smits wanted a custom feature from a BLHeli32 ESC. And here's the problem. BLHeli32 is closed source. Only the BLHeli32 developers can modify the firmware on a BLHeli32 ESC. BLHeli S is open source, and lots of people are working on modifying and improving it. Open source is awesome, but the problem is BLHeli S ESCs are slower, they have less processing power, they have less memory, and they just can't do as much as BLHeli32 ESCs. So Pete Smits gave up and went on about his life. No. Pete Smits sat down and started working on a whole new firmware for BLHeli32 ESCs. And as you'll see in this interview, that's what today's video is an interview with Pete, he thought, oh, just write an ESC firmware, how hard could it be? And 2 years later, here he is, and it's basically done. And in fact, right now, if you want to use this firmware, flashing it onto the ESC is a little bit cumbersome, but Diatone is working on ESCs with this firmware already on them, and I'll make a video about that when they finally come out. But today, I would like you to sit down with me and meet Pete Smits, the guy who just one day wrote his own firmware for ESCs from scratch because he thought it would be cool. And I'm really excited. I'm excited. I don't know if you can tell. I'm excited about this because some of the work that's going on in this AM32 ESC open source, they're making ESCs do things really cool that like people don't think, why would you do that? But you can now that there's an open. Anyway, on with the interview. Well, I guess I would ask, like, what motivated you? Tell me the story of how you came to do this. Like, what was it? Just like a passion project? Did you see a deficit that you wanted to solve?
Well, I've been doing hardware for longer than I've ever written a line of code. And now I was making hardware for Simon K firmware back in the day, and then when BLHeli became a thing, I was making hardware with and coming up with anything that pops into my head. If there's a new part on the market, I've got to try. And if it's a new MOSFET that comes out from a manufacturer, or a new driver, or a new MCU, I got to try it. So it's and then I actually started making some 32-bit controllers on this MCU called the ST Spin 32, which is a little all-in-one microcontroller and gate driver, and it was pretty cool. And I'd asked Stefan if he would license a version of BLHeli32 to me, because I wanted to just buy it, and I didn't want it. I knew it was closed source. I said, "Hey, can you license? I can register the UID of the chip, and we could just license a copy." And he wouldn't do that. So, and I'd already made the boards at that point in time, so I thought, okay, well, that's kind of. I didn't really want to start writing firmware at that point in time, but unless
you had
paperweights.
Back up. You had a custom hardware that you'd built, a custom ESC, because you were interested in trying out these different, FET drivers and processors and so forth to see if you could get better performance or just out of curiosity, but you needed software to run on it.
Yeah.
And BLHeli32 being closed source, you couldn't just flash it and he wouldn't license it to you. So you were just like, okay, I guess I'll just write my own.
Well, and there was a bit of time in between where I thought I was going to be able to, which I probably wouldn't have even started the hardware project. But way back in the BLHeli S days, I said, when he announced BLHeli32, I said, well, can I buy a license for a hobbyist when you've got BLHeli32 out? And he said, I'm sure we can arrange something. So I thought, that's great. Well, I made some hardware, and then when it came to it, it was just, and he was very polite about it. And he said it's only for manufacturers, and I'm only going to deal with hardware manufacturers and not individual hobbyists.
Well,
that's the way it goes. So
I'm sure that was disappointing. I don't want to sound like we're piling on Stefan, who does a ton of work.
And it's I wanted to use his firmware in the first place. I think BLHeli is great. And I probably wouldn't have started this project if I had known how much work it was going to be. That was 2 years ago now. And I thought, how hard could it be to get a motor to spin? It's just, like you just need to make something go in a circle, right? Like, but you know, there was a lot of work involved.
Famous last words. Now let me ask you, why didn't you use BLHeli Because BLHeli is open source. I'm sure there's a good answer for that.
Yeah, well, I mean, the big thing was, I mean, some of the BLHeli was getting to the end of its days when it comes to new capabilities. And well, I was trying to make a sensorless speed controller at the time that used SPI as an input. And that just wasn't something that was even, unless I asked Stefan to code me some SPI input for BLHeli, which wouldn't be on his radar. I mean, I couldn't understand assembly. It just didn't.
I see. Right, because BLHeli was written completely in this crazy, obscure assembly code that like 5 people in the world, I'm exaggerating, but not by much.
No,
so even though it was funny to me because although it was open source, almost no one else in the world could actually work with it because it was so obscure.
Yeah. No, I mean I had actually written an Arduino-based sort of ESC program before, so I wasn't completely new to it, but I couldn't understand a single bit. I just got so lost every single time I stared at BLHeli. I couldn't understand it at all, and I still can't to this day understand.
No. Now, why did you want an SPI-based interface for your ESC? What's the advantage of that compared to how we do it now?
Well, that was actually for a sensor. There was a sensor called the MA700 and MA704, and it's a position sensor that uses, it's a magnetic position sensor. So it's just like an encoder, but a very high resolution one. And unlike an encoder, it can go up to about 60,000 RPM or something ridiculous like. So it's you could essentially make a sense. It was for ground vehicles. Make a nice end of shaft sensor that can go onto in-runner motors and give me 0 to whatever RPM in ice control.
I see.
It was one of those ideas that just sort of fell to the wayside, like so many. But that was one of the reasons for wanting a 32-bit controller. And also, there's more things you can do with the timers. The resolution of the timers, especially in the 8-bit processors, once you get, if you can see it in the DSHA resolution as you get higher too, it's they're really pushing the limits of what they can do with them, and it's and I'm working on some field-oriented control, and I have been for years, ESCs, and that's all 32-bit based because you really need heavy math functions. And so it's, I think for me that, I program in C, and I don't, I could rather not try to learn assembly and go through all the bits and bytes. I just want to work on the higher logic.
Well, given the choice between decoding BLHeli's assembly and just writing it all from scratch, I can totally understand why you wrote it all from scratch.
Well, it was,
That's actually the rational decision, now that I understand it.
Yeah, and I mean, to get it spinning was actually really, I thought I was going to do amazing. It's the first week I had this motor spinning. I was like, this is no problem at all. And then D-shot, holy crap. And then bidirectional D-shot, and the amount of coding that you have to go through that was just, But I mean, I wanted to keep all the code original, and I wanted to try to, even if it's not the best way to do it, I mean, it's all open source and it's all fairly legible, so somebody can maybe read my code and write it out in assembly or put it in, do it better. I'm sure people out there are doing it better already. But
it sounds like there's a potential here for the AM32 project to be an open source alternative to BLHeli32. Because other people who maybe want, like there are people right now like Joe Lucid and JESC or Jazz Maverick who are extending BLHeli far past what anyone thought was possible. But like you said, they're hitting the limits of what that hardware is even capable of, and they can't really, where are they going to go from there? And now it sounds like maybe AM32 is a place to have a code base that runs on more sophisticated hardware. I don't know.
Yeah, and it works. And I mean, I know Joe is, or Thorsten is his name. I bet.
Yes,
I'm not
yes.
sure, but
Thorsten Lau, I think is his name.
yeah, and if he took my code, he could do some amazing stuff with it, and probably. I mean, it's a lot easier to understand and add to, but everybody seems to want to do their own thing. And he's online with us at this sort of started off in the chat spaces of the beta flight open ESC firmware group, where we sort of I had a little bit of working firmware that wasn't very well written a few years ago. Never had any sort of commercial intent to make it work on other hardware past my own. And Joe Lucid was always there working on his own, just flogging the BB2 to death. I mean, he just tried to get every last little bit of performance out of it as he can. And we were just saying, like, why don't you help us with this? Why don't you use this and help us? It's a process. It works. It flies. It works great. But it just, he liked to do his own thing. And then Jazz Maverick was on there too, but he didn't listen to anybody.
I've heard that.
So, so it just became something that I pecked away at until it eventually reached a point where it sort of was a tipping point where I think it was the configurator. I think once I got the pass-through working with BLHeli, so you no longer had to take your ESCs out of your quadcopter and solder onto them, and so now you can just plug in a USB controller or a USB port and away you go. That was really the point where people started using it, and it's
well, let me ask you. So right now there are no commercially available ESCs that come with your firmware on them. Is that right? So how do people, if they want to try this, how do they? Because you sent me some ESCs that you had already flashed. If somebody wants to try this, what do they need to do? Well,
it's really my design for it was for hobbyists to put on their own hardware, right? So that's really who I support, people who make their own hardware. I do have a set of firmware instructions and flashing instructions to remove BLHeli from an ESC and put AM32 on, but I don't know if I would do that. I mean, it's like taking a perfectly good working engine out of something and replacing it with something else. So
you say that, but the same thing that motivated you to do this project in the first place is going to motivate somebody else to try out AM32.
Yeah.
Does it require a special programming adapter, or is it just done through USB?
At the first run, it would require an ST-Link, and it's because the bootloader that for BLHeli32 is locked, and the ESCs are readout protected and write protected. You have to unlock some option bits through an ST-Link to even make the chip writable. So that's the unfortunate thing. And then once you've done that, you can upload a bootloader that I have that is on my repo on GitHub. And then from there, everything is done with just through pass-through and BLHeli suite, BLHeli configurator or AM32 configurator. They both work with it right now.
Gotcha. Now I'm looking on Amazon and I'm just seeing ST-Link programmers for like $10. Is that what you're? Is this like an expense? And do they have to solder it onto pads, or how does it connect to this chip?
Yeah, pretty much all of them have. Every 4-in-1 has those little pads on it.
I see.
And you just have to, what I made is a little set of they're almost like little pins. So just two little needles, and I just sort of stab them onto the pads on the board close together. And then while I'm holding them there, I press the buttons too.
Gotcha.
So it's kind of a, but there are some, for some commercial ESCs coming out, I suppose. I've been paid some royalties for them. So I imagine
so.
So I don't care if they come out now, but they're going to be out there, I think. And Diatone, so that's why we've got 3 Diatone targets that are that are actually properly named targets, and they have proper dead times matched for their hardware. And those ones are because they gave us a little bit of money, and they have so many controllers that they want to put out with this on it. And they would rather actually, they said they wanted to do something instead of doing it for free, they'd rather pay us a little bit.
I hope that they're compensating you fairly for the amount of benefit that they're getting in terms of not having to pay however much the royalty is for BLHeli32.
Yeah, well, and that's the tricky thing. I mean, it's nice that I'm getting anything at all because it is open source and they can just
that's true.
Make a target and
Fair
release
enough.
it. And that's what it's hard to keep tabs on that, really. Who's going to use it, what they're going to use it for, and how many people are going to use it. And really, if we start getting a lot of support requests, then we'll say, look, who sold you the ESC? Who made it? Go to them, ask them.
You're going to end up in the exact same position that Stefan did when they shifted from BLHeli to BLHeli32. I mean, they started charging money for BLHeli30. I was so impressed. And I'm not that I'm not impressed now, but when BLHeli was out, I would see people almost literally begging Stefan to take, they're like, please, will you take a donation? Can I contribute? And they said no. They just refused all donations from people. They just wanted to make this. And only when the support requests got to the point where they were like, we can't do this anymore, did they switch to BLHeli32, which was a licensed model. And they were like, well, I guess if this is our job, we may as well get paid. So here's your GitHub repo. And
so AM32 multi-rotor ESC firmware on the right-hand side here.
Okay, got it.
And then under release,
got
there
it
for now.
And then I'm going to plug in USB on my flight controller.
USB first.
Plug in a battery, right?
Yeah.
Then where's
serial
my
port
EXE?
connector EXE. It's at the very bottom there.
Ah, great. Okay.
And then you should be able to find your serial port bottom left.
Will it connect automatically?
No, just hit connect.
Oh, okay. Hit connect.
There you go.
Okay. And now what?
And now you should be able to click on a motor.
One at a time or all four at once?
Click at once. One there.
Okay. Connecting to ESC number 1.
There you go. So that means it just read all these the settings from that ESC.
I'm looking at these options. The options look pretty standard. Reverse rotation. Now, variable PWM, that's something that BLHeli32 has in their nightlies, but have not released yet. Hang on, let me make you full screen again.
Yeah, he actually gave me credit on his forum there about coming up with that one. But variable PWM, it's pretty cool. It solves a lot of problems, and I mean, I do it a little differently than he does it right now too. And I think that my option, well, I'll explain it a bit first. But first of all, the problem with a fixed PWM rate and a motor spinning is once you get to motor frequencies, commutation frequencies that are approaching the harmonics of the PWM rate, the motor actually wants to sort of stick to those frequencies, and you see bumps in RPM, and you see that the RPM will sort of stick to those commutation rates. So variable PWM frequency, first of all, always changes the PWM frequency based on the rotation speed. So
that is just hold on. You just blew my mind a tiny bit.
It's pretty cool.
That is. So I've always thought about variable PWM from the perspective of the torque, that at higher frequencies you have less torque. And so when I thought about variable PWM, I thought about low PWM frequency at low RPM, high PWM frequency at high RPM.
That's kind of a small side effect benefit of it too.
You just blew my mind. You're specifically avoiding the harmonics of the motor RPM.
And that's
insane.
That's where mine starts. So right before, mine stays at 24 kilohertz until the motor is at about 11.5 kilohertz commutation speed. At that point, I start stepping up the PWM frequency proportionally with the speed of the motor. So it never reaches that point. And that works for 90% of the motors in their range, that you don't see any RPM discrepancies and you don't see any stiction. And it makes it so smooth. You get this nice, very smooth feeling from start to finish. And it starts off at 24 kilohertz and ends up at 48 kilohertz. If your motor goes faster than a certain, you will find a sticking point. But generally, when you're at full throttle, you don't care so much. It's in mid throttles,
Right,
you notice
right.
it's like
Yes, at low RPM, you're concerned mostly about torque because you need to stabilize yourself at low RPM, and at mid RPM, you're very concerned about those harmonics because during cruise you'll just get these little jitters and shudders, right? But at high RPM, you have plenty of torque because the motor's just going hog wild.
Yeah.
And smoothness, I mean, you're just at such high RPM that you're usually not concerned so much about smoothness when you're at full throttle.
Yeah, exactly. And it doesn't really seem to, I mean, the torque difference, I don't know. I'm not going to, I'm talking out of my ass here. I don't know anything about torque.
So am I. Don't worry,
but when it comes to PWM frequency, it really does, like, as you get higher in PWM frequency, you do lose a little bit of torque in the high end. I mean, it's your dead time gets longer proportionally as a proportion of time in total. So you lose a little bit of your driving power. You lose a little bit of your braking power. But you do avoid those PWM harmonics, and you make the even just staying at a higher fixed PWM frequency, you make the PWM harmonics lesser. But doing a variable frequency that stays with the PWM frequency and just keeps it barely out of range, it does have a nice effect. And you can see it when you do a 0 to full RPM curve, and it's a dead straight line all the way up, which is
interesting.
It's pretty cool.
That's really fascinating. That's interesting, and it'll be interesting to compare that to how. So how does BLHeli32 doing it? Do you know?
Well, I think he's going to do it like I do it once he.
Okay.
But
once
right
he sees
now,
the advantage.
He just picked a 0 to 100 and starts off at 24, and at full throttle is at 48 kilohertz or 96 kilohertz. It's not based on commutation frequency like mine is. So it's
gotcha.
So I think the difference is the BLHeli one is based on throttle. Mine's based on the speed of the motor.
Because I saw that you have motor poles in the configurator, and I was like, well, why? The reason you need motor poles is because you want to know the motor RPM, the actual RPM, which Betaflight uses that for the RPM filter, but I couldn't figure out why the ESC needed that.
Well,
but
there's
now I see.
Another BLHeli option that you've probably seen, which is low RPM throttle protect. That's in the configurator. And what is low RPM for BLHeli? I mean, it's a fixed number. And so that's the thing. And that's why there's some problem with people who run big motors with it, because you either have to turn it off and on. It's a fixed amount. There's not a, so I have the same thing. You have to restrict throttle at very low RPMs. Otherwise you'll just blow motors left, right, and center. But mine is based on the actual RPM on the motor poles and the KV rather than a fixed number. So it's not something that below a certain RPM, it's restricted. It depends on the motor. So.
The flip side of this is that anybody using this feature is going to have to go into the BLHeli or into the configurator and put their motor poles in the ESC, which it would be super cool if there was a D-shot command that could communicate that information, because people are not going to be thinking to do that.
It would be, no. And I set my default to the same RPM as the BLHeli one. So it's, if you don't select anything, you don't ever go into the configurator, it'll work just like you expect. You'll have to turn the option off if you're going to use it with like 6,000 kV motors.
I was going to say, I mean, you go up to 48K, but if you're going to use this on like a, let's say you've got a 24,000, I'm just thinking the highest kV motor I can, like a Mobula 6, a little 24,000 kV 1S. Like, is there a point where the RPM gets high enough that you have to go above 48K, or do you just say, screw it, we're not going to worry about it because of the high throttle RPM?
Yeah, well, I mean, in terms of PWM frequency, see, right now, I don't really, most of my firmware is for pretty generic hardware, and I don't think most of it can support 96 kilohertz. So once we start supporting more specific hardware, then we will start pushing PWM frequency up on those ones. But right now, I think that it's 48 kilohertz is really, it does pretty well for the most part. And it's, even for little motors, it's pretty good. And you can sort of make up for the efficiency difference by just increasing the dead time.
Well, that's what I was going to say. The other argument for 48K is that, especially on small quads like Tiny Whoops, you get significant increase in flight time, and people have suggested that's related to the dead time, although I don't know the details. But it sounds like what you're saying is you could just manipulate the dead time and leave the PWM alone and still reap those advantages.
I have a feeling you can, and I've done, I haven't really done too many tests on little motors, but I mean, if you reduce the braking cycle considerably, that it'll make a big difference for little motors. I mean, there is some loss in the motors, and a higher PWM frequency does reduce the inductive loss of the motors, because those tiny little motors are just like a dead short of wires. Too low of a PWM frequency, and you just see this massive torque ripple. I think that one of the biggest differences, and one of the things that happens with our drivers, is that as we go up in PWM frequency, we get disproportionately longer dead time, because we're taking our dead time out of the braking time only. So we're doubling our dead time each time we double our PWM frequency if we keep our driving time the same. So if we still go from 0 to 100 when it comes to our on time, when we double PWM frequency each time, the only thing we can be doing is doubling our dead time, because we still have to go from 0 to 100, on time. So, and we've talked about this quite a bit too, and we've never really been able to come up with any conclusive answers yet, because a lot of us just haven't done the tests, and we really should. I mean, it's but I think that with a BLHeli ESC, you can probably test it out, because I think you can change the dead time. I think there's adjustable braking, which is an option, so you can probably just set it to 48 kilohertz and reduce the braking and see if that gives you more flight time. And I think that it probably will. I think that it's you'll probably see about the same difference in flight time. But I don't know. I'm just talking out my ass again.
Yeah. Well, that's where it all starts, right?
Until I try it,
you start with talking at your ass, then you do some tests and you find out if you were right. But
that's right.
We call that a hypothesis, right?
Yeah.
It's talking at your ass.
Yeah. I mean, when you say things, you end up saying a lot of things wrong. And I say a lot of things in forums and have to go back on what I say. But that's how I learn a lot of the things too. Yeah. I say it and then I research it myself after I say it. I'm like, I shouldn't have said that. That's really silly. But
I'm going to, now that we've got the latest firmware and the updated settings on this, I'm going to go give it another try.
It's and just have fun with it. And if people ask you a question about it, just tell them not to be scared about it. We're supporting it. It's I'm going to keep on working on it forever, and I'm not going to stop until it's. I mean, this works for flying, quadcopters and ground vehicles. It does brushed motors as well. It also works for induction motors. So, I mean, you could use this for just about anything. And it's what my intention is you have one firmware that can control any motor out there. And I'm hopefully lots of people will come and join the project.
It's especially exciting, I think, because I know there are going to be people out there who are interested in an open source ESC firmware that runs on modern hardware, as opposed to trying to shoehorn stuff into BLHeli S. I'm sure there's probably not a lot of people, because how many people are coding ESCs, but I'm sure that you're going to see some traction, especially once the Diatone hardware becomes available and people no longer have to use the ST-Link programmer. Although the kind of person who's writing ESC firmware isn't scared of an ST-Link programmer, to be honest.
That's the thing, yeah. So, I mean, it's most of my my user base, I probably got like 25 people use it right now. The handful of people I've sent off ESCs to, but most of them are people making their own hardware, and there is absolutely no option apart from this when it comes to an open source 32. If you want to make your own hardware on a new microcontroller, this is it. I mean, so that's really, so it has to exist for that reason anyway.
Okay. Well, do you know when Diatone is going to be releasing this ESC?
I don't know. I mean, the latest version is it's stable. We haven't blown up a motor in a very long time, which is good, and seems to be flying quite nicely. So really, I do it for the fun of it. So I'm trying not to get too involved in the business part of things, but you know, it's
well, I'm going to I'll ping them and see what their plans are, because I'm sure there will be people who are interested.
Yeah. No, there's a company called Neutron RC, which is going to be releasing some new hardware soon, which is a brand new sort of startup that I'm working with.
Okay.
And they will have some hardware that we've sort of designed the hardware and software from the ground up. So the speed controllers based on the G071 MCU, which is the same as KISS is using for their new FETTEC 4-in-1 ESC. A really nice little MCU. It's a big step up over the previous generation FO51s, and we're using the G431s, G474s for the flight controller. So we're moving from the F series to the G series, and there seems to be some big advantages to them. So we're focusing our new development anyway on the G series and the latest series of SD.
Yeah, everybody seems to be going to the H7, but other people have pointed out that the H7 has less memory than even the F7, and may not be like the best choice to go to.
Yeah, it's I don't know. I've got this little this one's a G474 on this flight controller here, and that one is right now. It seems to run faster than the F4s at a much lower power consumption, and it's I think those are just about the best flight controller processors that I've seen. All kinds of inputs and outputs. They run at 170 megahertz too, which is quite good math acceleration. And I mean, it's the logical successor to the F series. So it's and this one runs at 666 or 6,666 kilohertz gyro frequency, or 333, because it uses a new gyro 2 or something. I don't know. It's running really stable, and I've been pretty impressed with it so far. So I think that we're going to see more of those in the market too. Some new stuff is going to be coming out.
Yeah,
pretty cool,
it sounds like you got your finger on the pulse of the market, at least what's coming.
These are some cool little ones. So we're going to see some really small little 4-in-1s. There's this is it for that speed control. There's actually no MOSFETs on the back. Each of these devices, there's 3 of them on the front, is a driver and dual MOSFET.
Wow.
So that saves a place of 3 components each, which is, if the driver is normally the 4x4 size chip on its own, and then the MOSFETs would be 6 of those after the drivers. So it's combines it down to 3 4x4 millimeter chips, which is pretty cool.
Yeah. But what's the current capacity of that?
What's that?
What's the current capacity of it?
Not very much.
Oh, I was going to say, okay.
Yeah, I think that's meant for more like there's a bit of when the boards were sent to me, the company that sent them out, they said these things are rated for 30 amps to 60 amps because that's what it says in the data sheet. And it's MOSFETs, how they say up to 160 amps or 400 amps package limited. So they thought that they were making some 60 amp speed controller with it, but they do well for like a small whoop size board, which would be the kind of thing that, because they go on to a 20 by 20.
Yeah. Okay.
That's why I do this sort of thing. It's for the fun, for playing with new toys. That's where it's all just for playing with toys, isn't it? That's why we do all of this.
You say that. That's what it ought to be, right?
Yeah, we can't get too. It's
All right, Pete, I'm going to let you go. Thank you so much for sending this stuff to me. And we can talk again. Do you see this baby? Isn't he cute? Hit the subscribe button. Join my Patreon. Use my affiliate links. Or just keep watching videos. That's better than nothing.
Cuckoo Gaga, subscribe to my daddy.